Hello guys, welcome to my YouTube channel. Thank you so much for watching, and those of you who have not subscribed, kindly remember to hit the subscription button so that you can always share concepts in this particular platform. Now today a few of my fans had requested me to prepare a small concept in matrix, and I agreed, and I want to share with you a very basics of matrices. Basically the order of matrix, the compatibility of matrix, and symbol multiplication. Now, as I've said, we are going to look at matrix, and I'm focusing my lesson on order of a matrix, and we need to ask ourselves what is the order of a matrix. Now, the order of a matrix is basically the number of rows, and columns of a given matrix. Now, the order of a matrix could be 1 by 1, meaning that this matrix has 1 row and 1 column, or a 2 by 2 matrix, implying that this matrix has 2 rows and 2 columns, or even 3 by 1 matrix, meaning that the matrix has 3 rows and 1 column. Why are we insisting on the order of matrix? We are insisting on the order of matrix because it is the basis upon which matrices are operated. And I want to give a very simple illustration to expand further on why order is very, very important. For instance, matrix 1, 2, 3. This is a matrix of order 3 by 1, meaning that it has 3 rows. You can check. This is the first row, second row, and third row. And another matrix, let's call it 4, 5, 6, single matrix. And again, this is a matrix of order 1 by 3, meaning that it has 1 row. You can check, that's 1 row. But it has 3 columns. This is the first column, the second column, and the third column. So basically it has 3 columns. That's why it is a 1 by 3 matrix. Now, for multiplication to be effective, the number of columns should be equal to the number of rows in the second matrix. So number of columns in the first matrix should be equal to the number of rows in the second matrix. And you can check here that the number of columns is basically 1 column, and the number of rows here is actually 1. So you can check the two are actually the same. So when the two are the same, it means that this matrix can be multiplied, and therefore we say that this matrix is compatible. Now, the compatibility of matrix, therefore, is defined by the number of columns in the first matrix and the number of rows in the second matrix. Now, I want to give a very simple way of multiplying these two matrices. So the first matrix is 1, 2, and 3. This is a 3 by 1 matrix. And we are multiplying this matrix with the second matrix, which is 4, 5, and 6, which is a matrix of order 1 by 3. So remember, every time that we do multiplication of a matrix, we consider the number of rows in the first matrix and columns of the second matrix. That means we multiply the first row with each of these particular columns. And that's what we're basically going to do. You're going to multiply the first row, which is 1, and we multiply it by 4, so that we have 1 multiplied by 4. Then we multiply the first row with the second column, which is 1 multiplied by 5. We do the same, the first row with the third column, which is 1 multiplied by 6. We are through with the first row. We come to the second row and we multiply 2 by the first column, which is actually 4 there. So we have 2 multiplied by 4. Then 2 multiplied by the second column, which is actually 5. 2 multiplied by 5. And then 2 multiplied by the third column, which is 6. 2 multiplied by 6. We now come to the third row of the first matrix and multiply the first column of the second matrix, which is 3 multiplied by 4. And then 3 multiplied by 5. And lastly, 3 multiplied by 6. Now, this part can be simplified as follows. 1 multiplied by 4 is actually 4. Then this is 5. And then you have 6. And then this is 8. Then that is 10. And then 2 by 6 is 12. Then this is 3 by 4, which is 12. Then this is 15. And the last one is 18. This is 12. Hope it is visible. Now, look at the resulting matrix. And let's try to determine the order of this matrix. You can see that the number of rows here are basically 3 rows. This is the first row, the second row, and the third row. So the number of rows are 3. And the number of columns, therefore, are also 3 if you check. This is the first column, the second column, and the third column. So these are matrices of order 3 by 3. Why are we insisting on order? We're insisting on order because the order can also tell you the order of the final matrix. For example, in the first case here, the compatibility was being given by the number of columns in the first matrix and number of rows in the second matrix, which was 1 by 1. And therefore we concluded that these matrices could be multiplied because they are compatible. In the same breath, we can also find out that the number of rows in the first matrix and the number of columns in the second matrix gives us the order of the resulting matrix. And you can see that our final matrix there is actually of order 3 by 3. Now, that was a very simple lesson that shows why order of a matrix is very, very important. And we are basically looked at 3 things: the order of a matrix, the compatibility of a matrix, and a simple multiplication of a matrix that involves multiplying rows and columns.